everyone, welcome to the new lecture series of Vanguard IAS. Our subscriber base has been increased from 5 to 6 today, so I am happy for this. However, I would like not to waste 1 second of yours through these lectures. If I'm making a lecture, I will make sure that that will be beneficial for you from prelims perspective, and if you are trying to acquire some knowledge, then that will be absolutely beneficial for you. Okay, so if these questions which are on your screen, if you are able to answer all these questions, then please I request do not watch this lecture further. So if you are unable to answer one of these questions, or if you are not sure about this, then you can watch this lecture. So let us read this. Humidity, this is basically a true and false question. What does it say? Humidity is the amount of water vapor present in air. You need to tell it's true or false. If you are 100% sure, then you may leave the lecture after appearing the 7th question. Okay, latent heat is the heat required to change the phase of matter. The third question says capacity of an air parcel is more in a rainy season, and less in winter. In summer, dew point is achieved near the Earth's surface, and in winter, dew point is achieved at higher altitude from Earth's surface. Then the sixth question says relative humidity of two air masses A and B is 60% and 80% respectively. Then chances of rainfall is more in A. Is it true or false? If you are able and you are confident about these answers, then obviously I will say you should not watch these lectures. If the capacity of air mass decreases, its relative humidity also decreases. So far, if you are confident or if you are having any doubt, then you should continue watching this lecture. Let us start this lecture now. Okay, so basically I will explain you some concept. Right now, let's consider this is a air mass or a parcel of air. Okay, there are some points of humidity, that means water vapor, which is in this air. So these are called as humidity. Okay, these are called as humidity. Am I clear on this? Okay, so when we increase the temperature, then the capacity of this air mass increases. What is the capacity? Capacity to hold the vapor increases. Okay, so if I give you two air masses, air mass 1 and air mass 2, okay, and with increase in temperature, the capacity, if it was holding 5 particles earlier, if I increase the temperature, then it can hold another 5. Okay, with increase in temperature, capacity of air mass increases. Okay, however, the humidity, a term is called absolute humidity. Absolute humidity. Let us consider there is 50 ml water vapor inside this air. So the exact amount of water vapor is known as absolute humidity. Okay, and the water vapor that it can hold is known as its capacity, and capacity increases with temperature. Okay, when an air mass, at first here is sun, when sunlight falls on some water body, then the water vapor arise, and a air mass containing water vapor, when it moves upward, then we know with increase in altitude, temperature go down. Okay, with increase in altitude, temperature go down. When temperature go down, then what did I say? If temperature increases, then capacity also increases. If temperature go down, this is called adiabatic cooling. That means when we go upward, then temperature decreases, and when temperature decreases, then its capacity also decreases. That means it cannot hold the water vapor. It cannot hold the water vapor. It is the time when it will leave the water vapor, which we call as rain or precipitation. Okay. So you learned about the capacity, the term capacity, absolute humidity, that means the exact amount of water vapor present in a air mass. Then we learn with rise in altitude. With rise in altitude, temperature decreases, so capacity decreases. That means chances of rainfall improves. Okay, so let us now consider one thing. For example, this is a air mass A, this is an air mass B, and this is an air mass C, and this is temperature 1 degree Celsius, this is minus 2 degree Celsius, this is minus 4 degree Celsius. For example, this air mass A, when it goes upward, its capacity becomes less, or it is ready for rainfall at 1 degree Celsius. The point where its relative humidity is 100%. Now the term I used is relative humidity. What is relative humidity? For example, I have absolute humidity by the capacity into 100. For example, this is an air mass. Okay, it has 50 ml of water vapor. However, its capacity is so high. Okay, its capacity is to hold 500 ml. Its capacity is to hold 500 ml. I said the absolute amount of water vapor, it remains constant. Okay, it remains constant. When we go upward, absolute remains constant, that is 50, but capacity decreases. As I told, when we go upward, temperature decreases, capacity decreases. So think capacity when it become 50, that means into 100, if we will do 100, that means it comes to be 100%. That means 100% is purely saturated air. Purely saturated air. There is no room for any other water vapor. Am I clear? So this saturated air mass has lots of chance to clear or to initiate an precipitation. Okay, saturated air has the chances of more precipitation. Okay, if somewhere the capacity is below 50, that means this percentage will be less than 100%. If the relative humidity is less than 100%, then the chances of rainfall is down. If it's 1%, the chances of rainfall is very low. So when the temperature at which the relative humidity becomes 100%, that temperature, the minimum temperature, that temperature is known as dew point. When dew point is achieved, that means relative humidity is 100%. Now this air mass is ready for rain or precipitation. Now let's think the air mass B is getting completely saturated at minus 2 degrees Celsius. What does it mean? At minus 2 degrees Celsius, minus 2 degrees Celsius is the dew point of this air mass B. Okay. So I think now I'm clear on this. Okay. In winter, we know the temperature here near the earth becomes very low. That's why low temperature means low capacity. That means the dew point achieved close to the earth's surface, which is known as the fog and dew, or we get some precipitated form of water. Okay, let us now try to answer. Humidity is the amount of water vapor present in the air. Yes, absolutely right. Latent heat is the heat required to change the phase of matter. Yes, this statement is correct. Now let us try to understand what is latent heat. When this is a tub of water, okay, tub of water. When we reached 100 degrees Celsius, still we are providing energy, then it's boiling, but however, when we are checking, the temperature is showing 100 degrees Celsius, then where is this extra amount of energy that we are providing is going? Then that extra amount of energy is called as latent heat. Latent heat, which is used to change its state from liquid to vapor. Okay, so latent heat is the heat required to change the phase of the matter. That is clear, that is correct. Capacity of an air parcel is more in rainy season and is less in winter. See, in winter the air is dry, that means it can take more water vapor, so it has less capacity. However, in rainy season the capacity is less. In winter the capacity is more, and in rainy season the capacity is less. We can observe this phenomena by the cloth which we keep for drying in rainy season. It doesn't get dried soon because there is so much water vapor in the atmosphere. That means there is less capacity left in the atmosphere. So it says capacity of air parcel is more in rainy season. No, less in rainy season and more in winter. Okay, so this statement becomes wrong. Next statement is, in summer dew point is achieved near the earth's surface. In summer, no, in winter it is achieved near the earth's surface. So this statement is the interchange statement, so be careful for this. Then relative humidity of two air masses A and B is 60%. One relative humidity is 60% and another relative humidity is 80%. So which have better chance? It says rainfall chance is more in A. I will not tell this answer because this was the core of my lecture. If you have understood the concept, then kindly comment this question, which air mass A or B has more chance of rainfall. Okay, however I will answer in the end. If capacity of air mass decreases, its relative humidity also decreases. What we saw, relative humidity is absolute humidity by capacity into 100. If capacity decreases, then genuinely the relative humidity will increase because the denominator is decreasing. So it is obvious that relative humidity will increase. How? See, relative humidity, let's consider it is 100, capacity was 20, so our answer was 5. If this capacity is decreasing, being absolute, it remains fixed at 100, this becomes 5, then it becomes 20, so relative humidity increases. Okay, so this question says if capacity of air mass decreases, its relative humidity also decreases. So no, its relative humidity increases. So this question is wrong. So you will answer this question. This much for today's lecture. Thank you. Have a good day.